So, the warm-up question. So, the warm-up question's asking us is kind of a good exam review question. What are the reasons we know triangles are congruent? So remember, congruent means that they're equal, so that they have all equal sides, all equal angles. How do we know triangles are congruent? There was some properties that we could use. And I wrote there's 4 there, but there's actually 5 when I thought about it. Yeah, those are the ones. So like side, side, side. Do you guys remember some other ones?
Side, angle, side.
Side, angle, side. You guys got another one? Angle, angle, similar. Yeah, that's a good thing to kind of review. So this is for equal. If you're curious about similar, because we need to review that soon anyway. That one we have side, 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 angle, side, and angle, angle. But that's only similar shapes. That's a different. What's one?
Angle, angle, side.
Angle, angle, side. And another one. There's 2 more. Hypotenuse leg, yep, that's the easy one to forget about. Zippy's having a party back there. The last one has, because we can't do the naughty word. So our last one is angle, side, angle. But this is not a bad thing for us to review because this is going to be on our semester exam. So being able to prove triangles are congruent, being able to prove triangles are similar, so kind of reviewing some of that, that's going to be on our exam that will be in about 2 weeks now. So our exam is on the Wednesday of that exam week. And that day though, we do have 3 exams. So the first day we only have 2, the second day we have 3, the third day we only have 2. But then we're done early on that 3rd day of exams. Any questions about any of that stuff? Oops. It's obnoxious. So we're going to talk about today, so our congruence transformations. What that means is we're going to be able to, why does that take so long? We're going to be able to move triangles in different shapes along our coordinate system. And they're going to still be congruent when we're done. So even when we finish, they'll still be congruent. I wish there was a mute button, but there's not. I don't see one anyway. All right. So the different shapes you guys see here. So these are some different topics we're going to talk about here. There's different types of transformations. So
I talked about this in 8th grade.
and yeah, you might have, yeah, but this is something I wanted to bring back up because we have the time for it. And I think that's why I used to skip it in when we didn't have the time for it. But it shows up a lot on the ACT. I know in some of the practice ACT questions we've seen it. So I thought we'd use it and talk about it. And so yeah, if it's something you've already seen, perfect, and that will work fine. So different types of transformations. The first one's a translation, and I call that like a slide. So it like would slide across the page. And again, when you slide them, they'll be congruent when they're the same, when they're done. So they'll be equal to each other. Now, a rotation is when we turn the shape. So the shape is turned. So you picture like the moon moving through the sky. And again, these 2 are still congruent. They're just rotated. Dilation, I always think about going to the eye doctor because sometimes they'll dilate your pupils so they can look inside your eye more clearly. So dilation can either be like where they expand or can like condense, so it could get smaller. So it gets larger or smaller depending on what they want you to do. They might use the word shrink, enlarge, something like that. Now these shapes instead are similar. So they would not be congruent. So they would be similar to each other. And if you guys recall, we use a little squiggle for similar. And then a reflection, it gets flipped along the axis. And these are congruent as well. Now, what we're going to talk about here is the image, that's going to be our new shape. So it's after the transformation. The pre-image would be our original shape, so where we started from. One of the things that's really important with like a notation that we use is, so if I have a point A and then I have a new point, we call it A prime. So if I have a point A, it translates to A prime. So this is the new point. So they use that little, they call it a prime. It looks like a little apostrophe or a little like first power. That's a symbol they'll use a lot on the ACT, and a lot of times we'll have students come out of the ACT and say, well, they used this symbol, I didn't know what that meant. All it is it means the new version of that same point. So it goes from A to A, versus like here, it would have to rotate, so it might not just slide, it'll rotate around. Oh, I guess it was supposed to go the other way, sorry. So congruence transformations is what we're talking about today. So that's basically the three that stay the same size when it's done. So a congruence transformation is the image and pre-image are the same, are congruent. And so where we use those are reflections, rotations. Zippy's going crazy over there. And then translations. Flipping over. I was worried when I came back from break that he's dead. Like he's like laying in the water so murky we need to clean it, but worried we lost little Zipster. Now, when we do something like this, as much as you might say like this isn't very useful or something that you might think that it's not something you're gonna use in your everyday life, now anytime you like animate something on a screen, like I know when I did some computer programming in college, translations was a big part of that, like moving a character across the screen. You're doing a translation, either you're sliding it or flipping it or doing something like that, and you want it to stay like the same size, or like Mario is moving across the screen at the same size. But then maybe you shrink him down when he like gets hit by something and he gets smaller, but he still should look similar to the original Mario. So understanding that all of these different translations, transformations, are things that get used in a lot of the different graphics we see all the time. So obviously we don't go into as much depth as maybe you would like in actual computer programming. We're gonna see a little bit of that here today. So we'll do our translation first. And again, like Jackson said, this might be something you guys remember from middle school, maybe not. Oh no. I'm missing the top part. I don't have that top part. Oh, there it is. I don't know where it is. Okay. So our translation. So what's happening happening here is we're gonna move the x and y coordinates, like left and right, up and down, depending on what it is. So A, if A is positive, it's gonna move to the right. A is negative, it's gonna move to the left, like moving it left and right. Our y is gonna move up and down. So if B is positive, it's gonna move up. If B is negative, it's gonna move down. It's gonna shift our shape. So again, there was a similar question to this on our first practice ACT that we did, where they did a translation and they actually asked you for this part of it, they asked you how the x and y moved. We're going the backwards way of that, where they're gonna give us the shape and we're gonna have to move it. So we're gonna graph the shape. So a little quadrilateral here, a little four-sided shape. And we're gonna translate it the way they ask us to. So they're telling us to shift all the x values 4 units, -4, and the y values 3. So again, what this is telling us to do is -4, so that means left 4. And then they're doing +3, so that means up 3. Now you could take the time to take those and add each of them. I think it makes more sense just to look at my graph and kind of shift it over like we would normally do slope. So I'm gonna take each of these points and shift them over. I'm gonna go left 4 and up 3. And I apologize if I'm not in the right spot just because it's hard for me to count on here. So if this was W, we call this W prime. It's a second version of W. This is X at 2, 3. X prime. So our new shape should look the same, should be exactly the same size, same shape, but just moved over. It got slid over. Now, if they want us to use coordinates to describe a translation, so they say right 5 and then down 7. So all we're doing then is the right 5 means that I would take the x and I would do what with 5? What are we gonna do with it? +5. And for the y, we're gonna go down 7, so that means we're gonna subtract. So someone who knows translations would see a notation like this and know what to do with it. So being able to write it out that way, or write it on a graph, or use that notation. So again, on the practice ACT question, it basically showed the translation and then it asked you to figure this out, like what was happening to the x each time, what was happening to the y. All right. So our next one is going to be a reflection. And that means we're going to flip the graph over a given line. And a lot of times that's going to be one of the axes. So here we're going to flip over the x-axis reflection and then the y-axis reflection. They might give you a different type of line they could ask you to flip it over like another line on the graph, like y = x. So like flip it over the diagonal line, or y equals 2, like a flat line, and you have to flip the graph over one of those. But the ones we're going to do are just over the x-axis and the y-axis. So again, if I'm taking this first point, our x-axis is here, I'm flipping this graph over. So basically, I'm just going to have a mirror image on the other side at the same location, but the opposite side of that graph. So kind of checking, this one's up 4, I'm going to go down 4. Now the one right on the axis is just going to stay there. Again, this one's up 4, we're going to go down 4. And when I go to draw that, it should look like a mirror image as much as we can. And again, this lesson, I kind of like throwing these lessons in here because I thought they weren't too tough going into our exams, but at the same time, like still useful again for standardized tests or just something that we don't always get to in this lesson or this semester, that we can kind of add something in that we didn't quite reach, but isn't like super difficult to have to jump into. Now the y-axis is the vertical axis, so this one I'm flipping it left and right instead. So this first point, whoops, if I didn't move my graph here. Sorry, my cursor's a little bit off from where it should be. All right, so I'm right on the axis there. Like if I'm looking at this point, the opposite one would be right there. I don't know what's going on. It's like not touching where it's supposed to be. So I'm gonna have to just do my best here. Like it looks like I'm pointing to the X. I don't know. It works in some places. Okay. Hopefully you get the gist of it. And this might not go very well on mine, so we'll see how it goes. Now this one's definitely tougher to draw. Yikes. Sorry, my points aren't going on there very nicely. Don't do as I say, or don't do as I do. All right, and so our last thing here that we're working on today, and we're going to be done very early, but it's not the worst thing in the world. We can have some time to work on things and talk about grades are in a bad spot. We can talk about fixing that. This next one is one that maybe you wouldn't be obvious to you. So they're telling you the image, so they're telling you the new point. So this is the new location. They're telling us this is what happened to it. And we want to find the old location, the original. So where did we end, or where did we start from? We know where we ended up. So we took the x, and we had added 2 to get to -5. So we have to kind of do the opposite of that. So we're basically saying x plus 2 equals -5 if I want to know what the x is. So if I move that 2 away, bless you, that means the x began at -7. So we're doing the opposite of it. Same thing for the y. We're saying the y, the negative y was 4, or became 4. So then I would flip that. So that means y would have been a -4 to begin with. So, and you might say, well, we haven't done anything like that. Well, we kind of have, but you haven't realized it maybe. But just knowing that that's what they're telling us we're doing, we just have to follow that. Okay? Any questions there with that? I apologize for my graphing issues, and hopefully get better at that. So, what we're going to do for our homework is our homework is going to be a worksheet with this. There's going to be a lot of graphing or graphs that you'll have to deal with, but they're already on there for you. I apologize, the graph came out a little bit grainy. So if you have a hard time seeing where it is, some of the lines are kind of drawn like on the graph paper already. So you might have to be careful about that. I did say that you could skip 2 of them, so you can skip 15 and 16. I have them crossed off on here. But again, if you're, let me know if I can help with reading anything if you're having a hard time seeing it. So we have the rest of the time to get